This is part B of a discussion of the internet-based financial services problem. We've already discussed the basic ideas behind the simulation and the data that's included. We've even done a little back of the envelope sort of calculation to provide us with some numbers that will provide verification for our model. This number here and this number here will be valuable to us when we do our simulation to see if, in fact, our averages look like these averages. So let's see what we've got here. Here's our brain, and here's the data that's related to the call type, whether it's the client is curious, obsessive, or all business. Here are the times that are associated with each call type. Curious is normally distributed with 7 minutes and a standard deviation of 1.5. Here we're going to in the beta distribution, personal attention, we talk about the percentage of individuals that will need more attention than the time that they got during the discussion during the lunch hour. Here we provide information about what is a typical arrival rate, what is an atypical arrival rate on a day with a lot of volatility. 7 arrive on a day with less volatility, only 5 arrive per hour. And then here are the probabilities associated with a atypical day and typical days. 23% for atypical days, 77% for typical days. So let's build our simulation. This should not look very different from what we've seen before. I've laid out the demonstration here of the simulation in a horizontal fashion. I start with a random number that will allow me to calculate the type of day it's going to be. Is it typical or atypical? I'm going to take this random number and I'm going to go to a table, P3 to R4, which is over here, and I'm going to return whether it's a typical or atypical day based upon this random number. In this particular case, it was typical. If I recalculate, we can see that things will change. Let's see if I can get an atypical day. There's an atypical day. And subsequently, all the rest of the simulation changes also. So now I've got my day. Then I need to determine the arrivals. This is where I'm going to need two different Poisson cumulative distribution, discrete distribution probabilities tables to make that determination. If it's an atypical day, then I'm going to use this table over here, which is for 7 arrivals. And in this particular case, with 7 arrivals, 5 units actually arrived for a lambda average arrival rate of 7. Okay? If I hit F9, I'll recalculate. Here's a typical day. We had 5 arrivals. Here's a typical day, another 5 arrivals. Typical day, 6 arrivals. Typical day, 7 arrivals. Atypical day, 11 arrivals. Okay, this random number was used to go over here and find the right value. How? By looking at this if statement that says if you're typical, your lookup takes place here. If you're atypical, your lookup takes place here. So you're going to need that if statement in order to look for the right table. Then, as before, I create a bunch of different clients, whether they're all business or obsessive or whatever, by using the distributions that I've got here for the types of customers. So then I'll have the type of customer that I'm seeing. Out of the 6 customers, 5 of them were all business and 1 is obsessive. Once I know that their type of customer, the type of customer that's necessary, by the way, I use this random number, and I look up the type of customer in this table, as you can see. Once you know the type of customer they are, then we can use this fairly complicated if statement that says, look, if I've got no customers arriving, then my value over here for time for client is going to be 0. If I've got uh, something other than that, then if it's all business, I use this distribution. If it's curious, I use this distribution. And then if it's obsessive, the only one left is to use this distribution. So this takes the 3 different types of customers and calculates the time required for each. Then I calculate here a percentage from the beta distribution. This is a random number that's going to be used for the beta inverse function. And so 27% of my individuals of the 2 arrivals are going to be passed on to further analysis. I have to do a lot of rounding here because 27% of 2 obviously is not 1, but 27% is greater than a quarter of that. So I wind up with 1 customer that is going to be left. So 0.27 times 2 gives me a value of greater than half a customer. So but through rounding, this becomes 1 customer. And this sort of calculation takes care of itself over time. All right, that's the end of discussion for the data calculations of the internet-based financial services problem.